Hello friends, today we are going to discuss an interesting question which is also a previous year question of GATE. So try to pause the video and read it. So the question is, find the equivalent resistance across A and B with each resistance being R. So before solving the question, I will try to give you a quick recap about two concepts, one of which is delta to star conversion of equal resistance. So here is a delta circuit with three resistance being equal, which is R. We need to convert it to equivalent star circuit. So how do we convert it? We only have to do one step, which is divide all resistance by 3. So please try to remember this concept. To convert the equivalent delta circuit to star circuit, we only have to divide each resistance by 3. Please note the point that there are 3 equal resistances provided. So another concept is the Wheatstone's bridge balance condition. So there are total 4 resistances R1, R2, R3 and R4 and a galvanometer connected across this path. So the condition for bridge balance is if R1 multiplied by R4 is equal to R2 multiplied by R3. So R1 multiplied by R4 is equal to R2 multiplied by R3. That is, the product of opposite resistances must be equal. Then what happens? Then the current through the galvanometer is 0. That is, the galvanometer reads 0 value. So that is, the current through this branch is 0. So we can neglect this branch. So for an example, there are 4 resistances. We need to check the bridge balance condition. That is, the product of the opposite resistance is equal or not. So the opposite resistances here are 6 multiplied by 2 and 3 multiplied by 4. As we know, 6 multiplied by 2 is 12 and also 3 multiplied by 4 is 12. Both are equal. So the bridge is balanced. So the current through the galvanometer is 0. Then we can neglect the galvanometer. So whether it's galvanometer or any other passive element present here, the current through it is 0. So any passive element here also can be neglected. So here I have considered a passive element which is resistor. As the bridge is balanced, the current through this resistor is 0. So we can neglect this resistor. That is, we can open circuit here. Now we can easily solve this circuit with 6 and 4 being in series and 3 and 2 in series. 6 and 4 in series, that is 6 plus 4, which is 10, and 3 and 2 series, 3 plus 2, which is 5. 5 and 10 are in parallel to get the equivalent resistance. Now we can get back to the question. Now we need to find the equivalent resistance across A and B. Given in the question that all the resistance has equal value, which is R. So here is a delta circuit inside this circuit. First we need to solve this delta circuit inside it. As I previously said, here is a delta circuit with equal resistance. To convert it to equivalent star circuit, we only need to divide each resistance by 3. So here is equivalent star circuit. Now we can reconnect it back to the original circuit. As we can see, these R and R by 3 are in series. Also these R and R by 3 and these R and R by 3. Series resistances can be added. So they will add as R plus R by 3 as 4R by 3. Now try to pause the video and check if there is a Wheatstone bridge inside this circuit. So here it is. Here is the Wheatstone bridge. We only need to stretch this point to here so that we can get the exact Wheatstone bridge with the opposite resistances being 4R by 3 and R and 4R by 3 and R. And the galvanometer position occupied by this 4R by 3 resistance. Now we need to check the bridge balance condition. That is, the product of opposite resistances must be equal. So here the opposite resistances are 4R by 3 and R. So their product is 4R squared by 3. And also here R multiplied by 4R by 3, 4R squared by 3. So both are equal. So the bridge is balanced. So the current through these 4R by 3 resistance is 0. So these 4R by 3 resistance can be neglected. So here it becomes open circuit. Now we can reconnect this circuit back to the original circuit. So the 4R by 3 resistance here is removed. It will become open circuited because of bridge balance condition. Now we can easily solve this circuit with these two 4R by 3 resistance being series and these two R resistance being series. As we know, series resistances can be added. So 4R by 3 and 4R by 3 get added. Similarly, R and R get added. So it will become 8R by 3 and 2R. And these three resistances are in parallel. First, we will solve these two parallel resistances. That is R parallel 8R by 3. As we know, to solve parallel resistance, the simple equation is product divided by sum. That is, we need to take their product and divide it with their sum. That is R multiplied by 8R by 3 whole divided by R plus 8R by 3. So the simple equation for parallel resistance is product divided by their sum. So the equivalent resistance becomes 8R divided by 11. Now we can solve these two parallel resistances, which is 8R by 11 and 2R. So we need to use the equation product divided by sum, that is 8R by 11 multiplied by 2R, the whole divided by 8R by 11 plus 2R. Solving this will get us 8R by 15. So the equivalent resistance across A and B is 8R by 15. If you like the video, please subscribe to my channel for more such videos.